Okay, let's continue with this case. So now we're going to use Paraview to post-process the data, the output. So just launch our Paraview, and I would like to remind you, in the folder where you have the solution or where you were saving, you have these files. Okay, in these files we were just doing the automatic output. Okay, so also in the website you can download this file where you have more information. 1 second. So let's use this file, but pretty much we have the same data. Okay, so in my case I have everything. Okay, so you extract the folder, you will have the folder inside, and inside you have this file. So let's go here and let's open that file with Paraview. So I just like to remind you that you can also open the case files in Paraview. You will need to save the original extension without the .h5, okay, the original one. But the post-processing is a little bit more trickier, and these files are very efficient. I really like this format, okay? So let's open those files. So you go here, look for your file, okay? So I put my files here, and what you need to open, select here all files, and look for the one with extension ncas, okay? And here we'll ask you what is that format. No, it's not automatically recognizing the format. So you go here and cite reader, okay? And now we read the file. So see that you press apply and we're reading the file, okay? So you have your standard Paraview, and here you can access all the fields, okay? So if you select the check mark, select or deselect, you will access those files. So these are your solutions. The dots means that it's node centered. If you see a box there, it will mean that it's box centered. So see that we have pressure, Q criterion, velocity. This is the vector, and then the components, okay? Each one separated. And then let me change the background color. I prefer to have it white, okay? Here you have the time control. So see that I saved 20 time steps. So from time 30 to 31. So this was a simulation that ran a while. So we have a good solution. And see that we access the time here. So here you time controls. Go back to the first one, advance, and play. Okay, so let me stop here. So this says that we're accessing the fields, okay, but I want to access a specific patch. Okay, to do that one, you have here filters. You go alphabetical, extract block, this one. And this one will let you choose a specific section or region of your mesh, and then you can visualize or apply more filters in that section. So let me select the fluid, which correspond to the whole domain. By the way, these names are coming for Fluent, exactly the same names that you see in Fluent, you will have it here. So the fluid here, you see the eyeball. I don't want to see that region. Then I want to, from this one that I have everything, I want to extract another one, extract block, and I want just to have the square. Okay, you have the square there, and then there you can plot whatever you want. Okay, so I will leave there pressure. I forgot to save y plus. It would have been a good idea, but it doesn't matter. But you can compute it as well. New, you can put your derivative. So let's put a color there, a uniform color. So for instance, this block, see that we have the whole domain. If I want to get the Q criterion, I will apply here a contour of what Q criterion, choose your value, 100, apply, and you have it there. So now it's colored by the Q criterions. You want to use a different color, solid color, and then you can change the color here. Okay. Whoops, move it there. And as you press play, you have your animation, okay? So this was the Q criterion. So for instance, stop. So I want now a cut plane. Always I want it in the volume. So you have the option here, slice, and you can choose the direction. We want it normal to Z here. Do not show the plane. And then you can choose whatever you want to see there. So you have the velocity with all the components there, or you can use a specific one there. So let me hide that one. No, I want to hide contour. And see that now you have that one there. And okay, this one I can change the color. Put it green. Okay. And if we press play, you have there your solution. This end you have all the filters. Also we already did it for the case for the budget, so you can do sampling in a point, in a line. Okay, you have all the options. So this kind of post-processing is very tricky to do within Fluent. So Paraview, we can use it, and it's very easy to use. For instance, what else can I add? So you have streamlines, you have many options there that you can play. So let's use just the basic one. So we have cut planes, we have contours, and pretty much I have to say that that's all. So let me do, so for instance, we have here some unsteady solution, so we can compute the statistics of that field. So let me go and let's say that I want to compute statistics in this one. If I go to filters, alphabetical, see here that you have many filters, so you can play with all of them. So, but I would like to use temporal statistics. This is just telling you that this might be time consuming. Okay, so you can choose, I want to compute just the average. Okay, you have all minimum, maximum, standard deviation. So it will take every single time step that you have and it will compute your average value. Probably the standard deviation to get also the RMS from that value, the fluctuation. So remember, would be minus this one, the RMS. So standard deviation minus the mean value. And here you have the new quantity. See that you have the average and standard deviation. So your average pressure, which is not very nice. Let me see, average velocity. Okay, there was a problem. Okay, yeah, I think we need to compute it in the original field. So we need to go here. Okay, and need to get that one here. So let me go recent Western Pair statistic, and I just want to get just the average. Let's get for the moment. Okay, and I should have pressure average. Okay, now it's better. Okay, yes, you should have it in the original one. And then if one, you can do the same operations with the previously struct load or put cut plane. So let me add a cut plane there. And voila, this one corresponds to my average pressure. And then you have also your average velocity. Okay. And if you want to see this one, you will have the instantaneous one. Okay. So it's very complete Paraview. Okay, you have many options. I won't go in all of them. Okay, so I just will show you the most important one. So here you have glyph, which is vector. I don't know why they call it glyph. You can put vectors there. And you have many options to plot vectors. Okay, so we need to scale that. Okay, so you have the vectors, and I want to no scale array. Okay, should be the right one. Put 0, 1. You see it there, and I don't want to use. Okay, that is the orientation we need it, but I don't want to color the vector, so solid color. Okay, and see that you have the vectors there following your flow. And then you can, okay, you are not showing all the vectors. Also sometimes it can be too much, so by default you see here it's showing you just 5,000. So as you go here all points, it will show all your vectors. Okay, so if you have millions and millions of cells, that will be heavy to visualize that. Okay, so that was vectors, you hide there. What else interesting? So we have vectors, isosurface for the Q criterion, cut planes. Also we can use this one. So for instance, let me show you this. This, for instance, we can save also the L0 RL fields, and we can filter here. So basically you apply this one, a threshold, and you say that I want just to visualize, for instance, pressure. I want to see just negative values of pressure. So you go here, put 0, and it will show you only the negative value. Okay, so this is just equivalent to the one that we have been using within Fluent, that's not to show some values. So if you say RL here, you can choose what to visualize. Let me put minus. No, so minus 100. Okay. So you see low pressure regions corresponds to vortices. High show. For instance, the other one that I can show you to do, it is strings lines. Okay, so usually this is, here you have it. So there are many ways to use string lines. So usually we'll release from this line there. You see the line there. So you will need to move that line. So you have the coordinate here. So let me go and put nx minus 0.1. minus 0.1. Okay, and then y will be 0, 0. Yeah. Okay, so you have that line there, and I want to release there. So velocity, okay, apply. And I don't see the lines. Okay. Okay, I need to release compute particity. Where do I have? Okay. Oh, okay, yeah. You need also to apply in the right block. So that one you need to apply in the whole domain. So this one I apply it there, which is not the right one. So you can apply, for instance, in this one that, yes. So let me apply a string lines there that you have all the volume information. Give the location. So let me say that it goes from minus 0.1, 0.1. So let me hide there. 0, 0, so that you have the line there. Apply. So it's releasing the string lines, and you have it there. Okay, so also always be careful in where you are applying your filter. So here you will have all your operations, and you will need to apply the filters in the right one. Okay, and this is again will be unsteady. So if I press play, for each time I will compute, so it can be really heavy. So let me pause. And let me change the number of string lines that we are releasing. So you have many options there for the integration. And I want just to release, let's say, 100 lines. Okay, this will be much faster. Again, you can also change the style. So if you go into filters, you will have many options. So alphabetical, you have like tubes. Let me show you. You can put tubes there. Okay, you can constrain those lines to the surface. The same with vectors. So it will be a lot of styling now you can do at this point there. So just to show you again already the statistic. Remember that also we have the calculator. Okay, so if we go back to statistics and if I compute the standard deviation, okay, and let me apply here a calculator. Point data, I will call it RMS, so that will be you have the velocity, let me see, so standard velocity, okay, standard deviation, no, velocity magnitude, minus the average velocity magnitude. Okay, we have it there, and this will be the fluctuations, okay. So you can apply another filter to over filters and so on. You can do the sampling. Okay, you have, let me show you the animation. Well, we have Q criterion there, and will be the surface, will be this one, okay. For instance, you go filters, alphabetical, and you have here add annotation time somewhere, okay, annotate and filter, and it will add the times you want to have time. Okay, so to save the animation, you go here, save animation, straightforward, save a location, choose a format, so if you want a AVI, call it move, and choose a resolution, whatever, we use default values. This will be a warning, okay. So if I go here, I should have my movie here. Probably it should increase now the playback velocity, but this is it, okay. And I think this was a crash introduction into Paraview. So to Paraview to Fluent. So my advice: save the format. You can do pretty much the same using Fluent forward or Tekla or CGNS, but I found that inside, my advice using inside is very fast. It's lighter than the other formats. Okay, so use that, save with the given frequency that we did it. As soon as you have your given frequency, you will get all that data, and then you can open it here and do your post-processing, exactly the same post-processing that we have done so far within Fluent. You can do it exactly here, okay? So you just need to save the data, or using just primitive data, you can compute your data here. So for instance, if you get a set here, this one, for instance, filters, I go into filters, alphabetical, gradient, so you can compute gradients here. And there is a very interesting gradient here, is that use velocity. See here that you have Q criterion. If I apply this one here, I can compute also the Q criterion inside Paraview. No? I suspect the Q criterion only depends on the velocity gradient. So if you have that information, you can easily compute that. So go here, isosurfaces of what Q criterion is the name that is given there. I will put 100, apply. And this is Paraview Q criterion. So let me do here, you click here, you will split the windows in two, render view, you have another view there. Let me change also the background. I hate that gray background. And let me visualize in this one, right one, it is Fluent Q criterion, okay? And in this one, it is Paraview Q criterion. So if I right click here, link camera to this one, and they are now linked. Exactly. So there are some differences. Okay, probably in this one, I'm visualizing 100. And this one, visualize in 100. Okay, there are some differences in the grading, how they were computed, but pretty much you can get it also inside here. Okay, and again, just from the all your primitives data, you can get everything. So, for instance, you want to compute here L0 and RL, you will need K and X. Okay, that is coming from Fluent. So I think this is all for this tutorial. And the next one we are going to move. Okay, now the next one will show you grid refinement on the cases that we have, and then we move to last. Okay, bye, thank you.